lines is the major waste of energy and a huge problem. It's thought that resistance wastes up to 20% of all the electricity we generate. It's one of the greatest problems of modern times. And the search is on for a way to solve the problem of resistance. What we think of as temperature is really a measure of how much the atoms in a material are vibrating. And if the atoms are vibrating, then electrons flowing through are more likely to bump into them. So in general, the hotter the material, the higher its electrical resistance. And the cooler it is, the lower the resistance. But what happens if you cool something right down, close to absolute zero, minus 273 degrees Celsius? Well, at absolute zero, there's no heat at all. And so the atoms aren't moving at all. What happens then to the flow of electricity, the flow of electrons? Using a special device called a cryostat that can keep things close to absolute zero, we can find out. Inside this cryostat, in this coil, is mercury, the famous liquid metal, and it forms part of an electric circuit. Now, this equipment here measures the resistance in the mercury. But look what happens as I lower the mercury into the coldest part of the cryostat. There it is. The resistance has dropped to absolutely nothing. Mercury, like many substances we now know, have this property. It's called becoming superconducting, which means they have no resistance at all to the flow of electricity. But these materials only work when they're very, very cold. If we could use a superconducting material in our power cables and in our electronic apparatus, we'd avoid losing so much of our precious electrical energy through resistance. The problem, of course, is that superconductors had to be kept at extremely low temperatures. Then, in 1986, a breakthrough was made.
In a small laboratory near Zurich, Switzerland, IBM physicists recently discovered superconductivity in a new class of materials that is being called one of the most important scientific breakthroughs in many decades.
This is a block of the same material made by the researchers in Switzerland. It doesn't look very remarkable, but if you cool it down with liquid nitrogen, something special happens. It becomes a superconductor. And because electricity and magnetism are so tightly linked, that gives it equally extraordinary magnetic properties. This magnet is suspended, levitating above the superconductor. The exciting thing is that although cold, this material is way above absolute zero. These magnetic fields are so strong that not only can they support the weight of this magnet, but they should also support my weight. I'm about to be levitated. Oh, it's a very, very strange sensation. When this material was first discovered in 1986, it created a revolution. Not only had no one considered that it might be superconducting, but it was doing so at a temperature much warmer than anyone had thought possible.
We are tantalizingly close to getting room temperature superconductors. We're not there yet, but one day a new material will be found. And when we put that into our electronics equipment, we could build a cheaper, better, more sustainable world.
Today, materials have been produced that exhibit this phenomenon at the sort of temperatures you get in your freezer. But these new superconductors can't be fully explained by the theoreticians. So without a complete understanding, experimentalists are often guided as much by luck as they are by a proper scientific understanding. Recently, a laboratory in Japan held a party in which they ended up dosing their superconductors with a range of alcoholic beverages. Unexpectedly, they found that red wine improves the performance of the superconductors. Electrical research now has the potential once again to revolutionize our world if room temperature superconductors can be found. Our addiction to electricity's power is only increasing. And when we fully understand how to exploit superconductors, a new electrical world will be upon us. It's going to lead to one of the most exciting periods of human discovery and invention. A brand new set of tools, techniques, and technologies to once again transform the world. Electricity has changed our world. Only a few hundred years ago, it was seen as a mysterious and magical wonder. Then it leapt out of the laboratory with a series of strange and wondrous experiments, eventually being captured and put to use. It revolutionized communication, first through cables and then as waves through electricity's far-reaching fields. It powers and lights the modern world. Today we can hardly imagine life without electricity. It defines our era, and we will be utterly lost without it. And yet it still offers us more. We stand once again at the beginning of a new age of discovery, a new revolution. But above all else, there's one thing that all those who deal in the science of electricity know. Its story is not over yet. To find out more about the story of electricity and to put your power knowledge to the test, try the Open University's interactive energy game. Go to bbc.co.uk/electricity and follow links to the Open University.
A ringside seat for the changing of the seasons in Autumn Watch, back here on BBC HD from 8:30 tomorrow night. And coming up next, we're off to the seaside with Coast.